hope my screen is all set. Perfect. So, as usual, let me ask my very first question. Am I audible to all of you? To all the people in the meeting room right now and the people watching us on LinkedIn Live? Am I audible to all of you? Thank you for confirming, Dr. Tran. And what about others, dear attendees, other speakers? Thank you. And is that Galaxy A03 Dr. Sampurna? Dr. Sampurna Webster? If I'm not wrong. Is that you, doctor? All right. Thanks to all others who are confirming that I'm audible and they can see me on their screens clearly. Yes. And what about others? Come on, be active. This is just the beginning of the meeting. You can't be this slow and lazy. Come on.
We hear you very well, very clear. But thank you.
Thank you so much, Dr. Tred. And I'm just trying to keep up with our audience also. Let us make them more active. So they'll be here with all heart and mind. We can hear you. Yeah. Thank you, Sabiana. Perfect. I assume a yes from all others too. And with that, I'm trying to connect with the live stream as well, as this meeting is a LinkedIn live stream. All right. Let me confirm. We are having two other speakers in the meeting room right now. They joined it. I saw them. But right now, I think there might be a connectivity issues. And it always happens. So in case any of you are facing any connectivity issues, please feel free to join our discussion portal and write us right there. All right. So we can help you in any way we can. All right. Our team will reach out to you and help you. Here I am sharing the direct link for our discussion portal for this very event. That is neuroplasticity and mental health. All right. Welcome to all of you to our today's event, that is Neuroplasticity and Mental Health live conference. And firstly, I would like to know about the audience we are having in the meeting room. So if possible, please give me 1 minute and write about you, that what is your affiliation, your designation, dear attendees. That is for attendees, as we know much about our speakers already. So this is for attendees. Let me know, where are you from? Your full names, where are you from, and what are you up to? You are already a doctor or a student, and what are you expecting from our today's meeting? Just give me a 2 minute for this. Write it in the chat box. That will help me to know how who all are our attendees today. All right, the LinkedIn Live is also going well. Okay, people are asking me for certificates also. And that was a chaotic thing in our last event as well. So I hope I'll be very clear about it again, that the certificates will be provided to all the attendees and speakers who are in the meeting room right now, in the meeting room where I am right now, right?
Yeah.
So all those attendees who are in the meeting room right now who registered for the event will get the certificates when they will be present in the meeting for at least 70% of the duration of the whole meeting, right? 70% of the duration of whole meeting. Yes, this is the scenario. This is the policy right now, which we got from our management. I hope I'm clear. Yes. If you want me to repeat, I will repeat it again. So please do not hesitate to ask the questions, to share your views, to discuss with our speakers or within yourselves. If in case you want to ask something from me, please feel free to ask me. I'm there to help. All right. Again, I'm repeating, in case you are facing any connectivity issues, you can reach out to us at our discussion portal for this very event. The link I have shared in the chat box, and dear team, I think we should share this link to on the LinkedIn also. This will be helpful for all those who want to get connected in case they face any problem. If possible, please share the link in the LinkedIn Live as well. Okay, somebody asked me to share the certification pointers again. Okay, let me repeat. The certificates will be provided to the attendees and speakers who are present in the meeting room right now, right? The meeting room for which they have already registered, and all the details of this event were given to them on their email. All right. On their mailbox, they have all their login details right after they registered. So they will be provided the certificates. And there is one more necessity, that all these attendees who are in the meeting room and who will be joining the meeting room in a while also, they must be in the meeting for at least 70% of the duration of whole meeting. Example, if we are in this meeting for this, let me say, if the meeting goes on for 2 hours, then one must exceed 1 hour and like 40 minutes at least. All right. And I asked for it. I'm still not getting the details. As our very first speaker, Dr. Tran, is all ready for the talk, I want, I'm just asking for a time from him. I'm feeling like that. He was here in advance, and he's dedicatedly providing his time to us. I hope Dr. Tran enjoyed his coffee.
Oh, yes, thank you. Early morning here, you gave me a talk early morning, particularly Saturday. I supposed to have a, enjoy sleep late, but I had to wake up early morning, get ready, and here we are. So thank you.
Oh, thank you so much, Dr. Tran. That's very kind of you to provide us your precious sleeping time. As we know, yeah, we all know that generally doctors and the people associated with the medical fields are like highly busy, I can say. Yeah, it was very shocking for me when I got to know in our like previous event from one of our OCM, Dr. Nabil Habshi. She told me that she is on vacations for like 1 month, and I was shocked. I was like, wow, this is something which turned my own like views. about the life of a doctor. I never thought that doctors can have a holiday or they can have vacations also. That was my own personal perspective. What about other attendees? You still haven't provided the details. I'm not asking for the email yet. I will ask for the email address and your other details also for the certificate preparation. So please be attentive when I ask for it. The same information will be used for the certificate preparations, right? So I am getting a message from our other two speakers also. They'll join in a while. And there is a network connectivity issues. I have provided the solution already. So there are no worries about it. Dear team, please confirm if you have provided the discussion portal link in the LinkedIn Live as well. Just give me a yes.
Yes. No.
Okay, somebody is asking for the email also. Uh, okay, dear Muskan Gupta, somebody is asking me that they are joining the live, but they didn't get any email. Dear Muskan, you won't get the email like this. You need to register for it. If you want, we can provide the registration link also. Our team is already answering the question. All right. So, shall we start with our very first talk presentation, everybody? And I want everyone to be active for it. Come on, give me a thumbs up. We ready? Are we ready, everyone? Great.
Yes.
See, our speaker is all ready for it. Perfect. Ah, that's great. This is the response I'm really expecting from all of you. Let's dive in the informative ocean with Dr. Tran, and he will be the very first speaker. Let me introduce. So, everyone, he is Dr. Lloyd L. Tran, the CEO of Biomed Industries, USA, and he will be presenting the neurogenesis hypothesis, and that is a case study for the treatment of Alzheimer's disease. The screen is all yours, Dr. Tran. You can take over the screen, and all the very best from my side.
Can you see the screen?
Not yet, but please take your time.
Share the screen.
Yeah, perfect. Please take your time.
Can you share the screen?
Not yet. And please don't hesitate if you need any kind of help from our team.
Okay, let me see the screen.
Yeah.
Can you see the screen?
Yes, right.
Okay.
Now.
Thank you very much. I appreciate the invitation, and it's a pleasure meeting you all here. My name is Lloyd Tran. I'm the chairman and CEO of Biomed Industries. And I'm a scientist by training. I'm not a physician, but I have spent the last 20 years work on Alzheimer's disease. What the reason I get involved in this research, because 20 years ago, my dad had the dementia, and it really serious, and he died of Alzheimer's disease. At that time, I decided to focus my attention to work on this field. And Alzheimer's disease is one of the very dreadful diseases. I like to share you some screen. It is a progressive disease of the brain that's characterized by impairment of memory and eventually by disturbance in reasoning, planning, language, and perception. In the US, more than 5.7, almost 6 million people in the US, and about 75 million people worldwide have this disease. And I'd like to give you a big picture. Besides not focus on Alzheimer's disease, there are about a number of people have mild cognitive impairment, which is the early onset of Alzheimer's disease. And there are about 8.5 million people in the US. And also many people, before they have mild cognitive impairment, they're suffering from cognitive slightly impairment, but also they have certain kind of amyloid positive. About 36 million people have this kind of symptoms. Since 1995, the total expenses of research and development in this field estimate about $42 billion US dollars. Most of it, about 57%, occur during the clinical trials phase 3, and about 184,000 participants have registered and contribute time and inconvenience undergoing clinical trials. And even though today there are not much treatment or prevention, and I like to go over the situation with you. And let me see how, next slide here. One of the challenges in dementia and Alzheimer's disease over the past 15 years is so there are many major drugs fail in phase 2 and phase 3. And we have a record, so 2008, many drugs like tenofovir, semaglutide, pembrolizumab, and so on, by major drug companies, Eli Lilly, Pfizer, Johnson Johnson, Merck, Lundbeck, Roche, Biogen, and so on. Many drugs actually didn't make it, and there are reasons why. So the talk of my talk today is to go over a review of the centric of the method, amyloid hypothesis. I will spend a little bit of time to go over in depth of this hypothesis, because this has been the center of research guidance over the past 30 years. And after that, I will give you a talk about introducing a new hypothesis, which is the main deliverable of my talk, okay? So this is a long history, and I must tell you that over the past 30 years, almost all research on Alzheimer's disease focus on and guided by a amyloid hypothesis that back in the year 1992 postulate that the deposits of amyloid beta peptide are critically responsible for the neurodegeneration that occur in dementia and Alzheimer's disease. The influence of this hypothesis has become so great that over the past 3 decades, there are virtually no serious alternative approach been presented. And this kind of hypothesis almost considered as a main theme that most scientists follow. And if you not follow this hypothesis, likely you won't get funded. Your grant will be, rejected, because most of the PhD student, postdoc, even professors who work in this field have a tough time to get grant work in other field except follow amyloid hypothesis. So to my opinion, it's almost reaching the level that amyloid become a dogma. And according to distinguished philosopher Professor Karl Popper, he's saying that the dogma is one of the greatest barrier to scientific research. When you accept the idea without proven blindly, then you follow the dogma almost like religious without any kind of scientific belief. And this is a warning from Professor Popper. So, however, many loyalists of this amyloid hypothesis, they keep on changing. At the beginning, they thought it is a amyloid plaque, and then it doesn't work. So they say, how about a soluble, diffusible form of amyloid? Okay, does it make sense? It seemed like very hard to believe because the Alzheimer's disease pathogenesis follow a defined spatial temporal sequence that the neural loss is highly localized. So the idea that the amyloid beta is a soluble solution circle around the brain is very hard to believe, right? And by the way, at the beginning, many scientists raised the questions that how about the amyloid presence in many older people who are sound-minded, non-demented. Many older people, 70, 80, 90 years old, they die with a sound mind and they have a lot of amyloid, but they still sound mind. And many people have suffering from dementia, amyloid, and they have little amyloid. So it is quite conflict opinion, right? So today I'd like to present to you the challenge that this amyloid hypothesis has been facing, and I'm going to present the new hypothesis that may broaden the view. Okay, now interesting enough that in the research community, people thought that Alzheimer's disease is defined as the presence of amyloid plaque. So since you define the disease as a build-up amyloid, so it is like a circular definition. If you don't have the amyloid, then you don't have a disease. But if you have a disease, you have amyloid. So what's the point to confirm that the amyloid hypothesis is true or not? So it is a circular definition, right? So you circle around, you depend on A, but A depend on B. A, B are associated, but doesn't mean that A and B, A is a cause of B or B cause of A. So it is a circular together. Because of that, many scientists been misled by the amyloid hypothesis. And I like to go over a few points to tell you, and I hope that many young researcher or new researcher get into this field, try to have a critical mind to challenge the dogma. If we accept the dogma at ease, we never make any progress in scientific research. For example, this is a few reasons I want to tell you. The idea of the amyloid is the cause of Alzheimer's disease is very questionable because there are a lot of people, almost like 20, 40% of normally healthy people who die, okay, have a high load of amyloid, and vice versa. Some people have dementia, but they have very little amyloid. And amyloid beta is not something wrong with it. I don't know why people try to remove the amyloid because amyloid beta has normal functions in our brain, okay? And it is contradictory to the idea of amyloid beta is toxic, right? And most of the research over the past 30 years tried to remove the amyloid from the brain, right? And so we think that the amyloid beta is a normal part of the brain, and the idea to remove it is not a viable idea. So the amyloid hypothesis, by the way, as you and I know, hypothesis is just idea, right? You and I can have the hypothesis, but it doesn't mean anything until you prove that have benefit, prove it effective, right? So the amyloid hypothesis has been considered is the foundation of the treatment for Alzheimer's disease. They use the number of people who have a familiar genomic characteristic to demonstrate that, look, many people who have familial Alzheimer's disease, almost all of them have amyloid. Therefore, amyloid is the main reasons. Unfortunately, it's not true because the familial AD is only represent 3 to 4%. More than 95% of the Alzheimer's disease are not from the familiar, uh, genomic heritage, right? So the idea was very questionable. Also, the people saying that amyloid beta is bad, right? It's because the reason they call it bad because what happened is they isolate the amyloid beta in a culture cells, and then they say, hey, amyloid beta is toxic in a petri dish, right? But it's not true. The amyloid in the animal brain and human brain are essential for the brain activities. So removing that is not a good idea. And also the amyloid hypothesis are so centric, it's not considering all the effects, such as the metabolic deficiencies, metal ion, oxidation stress, and neurogenesis, which I'm going to present to you. So without further say, I think that this is summarized of the benefit of the amyloid beta in our brain. And when you appreciate the impact of the amyloid, you can see and explain why many drugs who have focused on trying to remove the amyloid beta failed, right? And this is the summary. The amyloid beta are essential for microbial antimicrobial activities, well, which is pretty good. It have antibacterial, it is antifungal, antiviral. So our human brain is a marvelous, a wonderful organ, right? Mother Nature allow us to have internal defense system. So the brain have the antimicrobial activity, fighting against bacteria, fighting against virus, and that thanks to the amyloid beta. And also the amyloid beta may intercept with some kind of cancerous virus, and it can suppress tumor growth. And also one of the major property of the amyloid is that it can seal any leaks in the blood-brain barrier. You and I know that blood-brain barrier is a defense system for our brain. Any kind of pathogens, bacteria, any kind of chemical, toxin, toxic compound, not easily cross the brain because of the blood-brain barrier. And the amyloid beta has ability to seal any kind of leakage in the blood-brain barrier. This is a wonderful property. And also, it is contrary to people thought, the amyloid beta actually help to promote quick recovery from brain injury. Let me tell you an example. Many years ago, there was a case report of a 10-year-old boy play sport, right? And the boy is very young, 10 years old, and he died due to the head injury, the brain autopsy showed that this boy have a lot of amyloid beta in the brain. How could a young boy, 10 years old, have so much amyloid? There was a theory saying that because the boy hit with a accident and the brain damage, and he died after many days. During several days, tried to recover, but it failed. The brain generate a lot of amyloid to protect the brain from further deterioration. So the amyloid beta is actually the result of an injury to the brain. It's not a cause of the dementia. And more data show that amyloid beta have ability to regulate the glutamatergic and cholinergic synapses. It helps to rejuvenate and strengthen the neurotransmission in the brain, particularly at the hippocampus. So, and this is one of the study clearly demonstrate that the beta amyloid, okay, ability to seal the blood-brain barrier to protect the brain from any kind of injury caused by pathogen or any kind of toxicity. Okay, so, and that is the theory over the last 30 years. So let me tell you, so what the big deal? So what the result of drugs company able to follow the amyloid hypothesis, right? And so what is the end result you got today? Last couple of years in June 2021, the FDA in the US approved aducanumab from Biogen based on two clinical trials. Unfortunately, those two clinical trials, phase 3, were correct to each other. One say work, another way it doesn't work. And however, the FDA approved it anyway because they believe that there is no treatment and many million people really desperately need treatment and then no treatment. Even though this drug is not perfect, it caused about 40% of the study participants suffering from serious effect, right? And however, there are no other treatment available, so the FDA approved it based on ability to reduce plaques, and the reduction of the amyloid plaques is reasonably likely to result in clinical benefits. In other words, the drug has not shown any benefit, but the FDA believe, this is a belief, right? Believe that the drug is likely, reasonably, to result in benefit. So I do not criticize. I think I'm in the pharmaceutical industry. I think this is a good, a very positive, a very generous gesture from the FDA, enable drug companies to bring forth the drug treatment, even though it may not be perfect, right? And in fact, one of the professor on the committee, Professor David Kopman, he published the the paper to challenge it, and he said that the post hoc analysis suggests that the efficacy of the drug is not reliable. And by the way, the drug has been approved, so thanks to that, we congratulate Biogen for get the drug approved. Unfortunately, that drug has not been utilized much because people worry about the toxicity. And then another drug just recently come to the horizon, lecanemab, is another drug target the amyloid. Okay, it is the amyloid related drugs, and unfortunately, about 7 people die in the clinical trials, and the FDA decided to approve the drug anyway, and it was approved in June 2023, a couple months ago. This drug, by the way, is very expensive. It costs about $26,000 for the intravenous infusion twice a day. And you have to have about $60,000+ cost of PET scan, MRI, lumbar puncture associated with it, because the drug entirely focused on amyloid. So to be able to administer the drug, the doctor have to monitor the amount of amyloid by using PET scan and all the techniques, which is pretty expensive in the US. I don't know all the countries, but the total cost about $88,000 per patient per year. And unfortunately, the adverse effect of the amyloid target drug was so severe. Not only lecanemab, not only aducanumab, I'm talking about the last minutes, but over the past 20+ years, there are many drugs such as tepinuzumab, solanezumab. All of them have adverse effect, which is causing the brain swelling, the microhemorrhage in the brain, okay? And these are serious. Some of them dying because of this effect. And they use the name amyloid-related imaging abnormalities, ADRIA, which is a very linguistic kind of definition to including brain damage and all the edema and microhemorrhage, which is potential fatal to the patient, right? So this is a trade-off. One hand, you remove the amyloid. On the other hand, you cause significant adverse effect, right? So where we are heading to. So this is the conclusion. Once again, the FDA approved 2 drugs in the US, aducanumab in June 2021 and lecanemab in July 2023, based on not so much about the factual data, but it based on a likelihood, based on a reasonably likely to result in clinical benefit, even though there are no clinical benefits, right? So I tell you, it's sort of a little bit strange, but we accept the FDA decision. However, in the US, let me tell you, I'm sorry that I tell you a little bit more centric. In the US, I don't understand all the country like India and Europe and many countries. You audience can can tell me later on. But in US, the Centers for Medicare and Medicaid Services, CMS, it is the center in the US to managing the healthcare services and reimbursement of all drugs, right? The CMS drew on on April 2022 that in that date, right, no trial of anti-amyloid monoclonal antibodies has currently demonstrated a clinically meaningful improvement in health outcomes, right, for Alzheimer's patients. Thus, according to the CMS, there is insufficient evidence to conclude that the use of monoclonal antibodies directed against amyloid is reasonable and necessary for the treatment of Alzheimer's disease. That's the ruling by the Center of Medicare and Medicaid. Now, however, under the pressure of many nonprofit organizations who are patient advocates, such as Alzheimer's Association and all the lobbyists for drug companies, Biogen, Eisai, Eli Lilly, under tremendous pressure US, the CMS agreed to reimburse these drugs with one condition, is that the treatment have to be monitored under the federal registry system, which is equivalent to collecting real-life clinical data in a large population of patients. In other words, the Center for Medicare decided that since FDA went ahead and approved the drug, even though the drug has not shown clear benefit, even though the drug are very toxic to the patient, right? They're willing to reimburse with one condition, that the patient have to enroll in something equivalent to clinical trials. In other words, the government decided to monitor every patient who administer this drug to follow through what's going on. And by the way, this is one of the most obstacle for drug company like Biogen, Eisai to get the drug to the market, because even though you can sell the drug, but the Medicare won't reimburse us unless the patient is monitored as if they were in clinical trials. So the end result, I think, very good. It is a balance in the US as a democracy society, everything possible you can push for, but there is a counter force, and it makes life very balanced. It is a accountability in the US government system. Okay, so now I want to shift gears. The question is, we spend so much time, there's so much, as you saw, there are many $billion spent on research development in the US and many countries based on virtually a single concept, an idea that have not been proven. So the question is, in the journal, they discussed about what if the current hypothesis for the cause of Alzheimer's is all wrong. I'm not me asking, but there's some journalists, they challenge that. They say, what if we thought about that, but since we only center on one idea, it might not be correct. How about other approach? In the US, it's sort of a very interesting country. The reason people follow this hypothesis without challenge, because the National Institute of Health, the National Institute of Aging, these are the big funder of US government. They spend many $billions a year to fund research development. Unfortunately, NIH and NIA believe that the amyloid idea is the correct one. So they fund almost 90% of the funding over the past many years to one single idea. And they do not fund any other idea. If you got the new idea, you have a tough time to get funded, until very recently, by the way. Over the past 20 years, I know many scientists, many doctors, friends of mine, they have a tough time to get funded. And sometimes if you do not follow the amyloid hypothesis, you get cut off. You won't get any renewal for funding, and nobody accepts your paper in the US. If you talk about something else, they say that if you don't believe in amyloid, you're out from the mainstream and you stay in the cold and you got to manage yourself and nobody support you. And that is one of the reasons my company decided to spend time and result to follow another process. We believe that it hopes to give another insight, another alternative approach beside the amyloid, right? Okay, with us, I begin to talk about introducing you a new concept. And we are among the very few scientists who will think outside the box. We think that the human hippocampal neurogenesis is a viable approach, okay? And let me explain to you. One of the unexplained observations of the Alzheimer's disease is that neurodegeneration takes place in the lateral entorhinal cortex before any other part of the brain. And this is something happening in that area close to hippocampus. And this brain does not have elevated amyloid at all. So unlike the idea say amyloid is the cause of the disease, we find that amyloid is not the cause of disease. There's something happening in the hippocampus, okay? And the unique feature of the lateral entorhinal cortex is that it has newborn neurons that has undergone neurogenesis in the dentate gyrus of the hippocampus. You and I know that in our brain, the hippocampus is an area which is critical for learning and memory. It contains neuroprogenitor cells that continue to generate new neurons through our life. Our process is known as the adult hippocampal neurogenesis. We all know that when the newborn child, were born, or even in the embryo stage, the brain develop with the brain continue make neuron when we were young. But everybody believe that when you are adult, right? We thought that the brain stopped making new neurons. That's the reason why we thought when we get old, people become absent-minded and you no longer have the thinking capability when you were young. That idea was not true because I know many people nowadays, they live in an old age, 80 years old, 90 years old, and they still have a very sound mind. The reason they have a sound mind because the neurons continue to generate in their mind, right? Now, so what happened? Okay, so this is the foundation of the new approach we are proposing over the past several months. I was invited to a few international conferences to present the hypothesis. Basically, we believe that the hippocampal neurogenesis is persistent throughout even up to 10 decades or even 100 years of age, right? So people can live to 100 years of age and the neuron continue generate at that time. And this can be detectable in people with Alzheimer's disease. Now, if you look closely, because a little bit time, I cannot go to detail, but the nestin, SOX2, and neuroprogenitors, and DCX cells, neuroplastic cells, and immature neurons can be detected in subject as old as 97 years of age, by the way, according to research by Professor Moreno and Tobin a couple of years ago. And we observed that there was a marked and progressive decline of DCX and decline of cell numbers in AD patients as compared to healthy neurologically patients. In other words, what the difference between the people who have Alzheimer's disease is that they lack the ability to make new neurons. Somehow there is a severe decline of neurons, DCX cells in the brain of the patient. And that makes sense because if our brain cannot continue make neurons, we could not offset the loss of neurons when we're reaching at old age. So the adult hippocampal neurogenesis impairment is the culprit of the disease. So one of the characteristics of the disease is not about the amyloid present or not present, but because of the lacking deterioration of the ability to make new neurons, okay? And by the way, the adult hippocampus neurogenesis takes place prior to the amyloid plaque can be observed. In other words, before you can measure the amyloid protein on our brain, if you measure it, then too late. Things happen well before that. So the amyloid virtually is the result of the disease. It's not the cause of disease. And that's the reason why many drugs fail by go after the idea of removing the amyloid. So in other words, we believe that the adult hippocampal neurogenesis serve as a new pathway. It could be a new approach for drug discovery, and that's what we've been doing over the past many years. Okay, based on that hypothesis, we're able to discover the drug. It is a small molecule drug. It's not the monoclonal antibodies. It easily crosses the blood-brain barrier. It generates neurogenesis, and it exhibits neuroprotection in the patient. We did phase 1, phase 2. Phase 1, so it is well tolerated. It has predictable pharmacokinetics. And our phase 2A confirmed the safety and efficacy of the drug. And we are in the process of phase 3. So once again, the concept is that the drug actually serves as the catalyst to make new neurons, to restore the neurogenesis. We believe that many people at old age, for some reason, they lost the ability to make new neurons in their brain. And this drug, we discover NA831, can help to restore the neurogenesis. It boosts up the number of DCX cells, and it increases the number of neuroplasts. As a result, it's able to help the patient stop the further deterioration, and with the hope that it can restore the memory and cognitive functions. Okay, we have so much data to tell you because of time limit. Let me go to a few things. So we did a phase 2A clinical studies of two groups of patients, people with Alzheimer's disease and people with mild cognitive impairment according to the procedure. The total is about 112 people participated. 64, over half, have MCI, and about 48 people also have mild and moderate Alzheimer's disease. And the adults, male, about 54%, 53%, female, about 46% or so. And their group of cohort patients consists of white or Caucasians, 60% Asian community, about 28%, and some Black community, about 10, 11%. And overall result, so observation over 6 months is that the patient improved the ability to concentrate, short-term memory, long-term memory, apparently to restore. And it helped the patient to able to, think clear in their mind, ability to self-care, they understand where they are. One of the characteristics of many people have Alzheimer's disease that they don't know where they stand, even in the house, they don't know, where the bathroom of the house is. And I, as a family member of my family, my dad, I know what it's like to be a patient, go through this period of dementia. And so the way we characterize this property is look at the ADAS-Cog, Alzheimer's disease assessment scale cognitive function 13. And this gives us a comparison between the cohort of people have AD and cohort people have placebo. So the blue line, you can see the blue line represent the cohort of people have a placebo, whereas the red line represent the cohort of patients have MCI over 6 months. The difference, about 3.8, represent a significant difference between patient take the placebo and patient the drug. You take a note here, but for the patient with mild and cognitive impairment and also mild and cognitive moderate Alzheimer's disease, you noted that the difference between the placebo and the cohort of patient take the drug a little bit clearer at about 4.1. FDA recommend that anything more than 2.5, meaning significant, any less than 2.5 different is less meaningful. So this one clearly demonstrates 4.1 scale difference between cohort of placebo and drug. Granted, it is a relatively a small number of patients, only 112 patients altogether, but it's clearly show a promising result for further phase 3 trials, right? And the results are very promising. We have presented this one at the medical journal and international conference in the US and other countries as well. We believe that the drug relatively well tolerated, easy tolerate. It is oral. You can take the drug 30 milligram per day, a little bit more, a little bit less, depends on the doctor prescription. There is a minor adverse effect for people in the mild and mild Alzheimer's disease have mild headache and diarrhea. The rest are very good, and then no serious adverse effect encountered for this oral formulation. Okay, because time limited, I want to skip through very quick because we compare our drug with the current drug, lecanemab. If you see the left-hand side, this is our drug NA31. On the right-hand side is lecanemab. You see that the lecanemab drug, actually, the profile or deterioration are both are very similar. The red line represents the cohort of the placebo, and the blue line represent the placebo. So for our drug, it relatively stable, but for lecanemab, it actually well deteriorated over many months. And also Eli Lilly drug, donanemab, follow the same pattern. It not strengthen the situation, but it declined the same pattern of the placebo. Okay. So at the result, this where we see in the market today. One thing I note that lecanemab, they claim about 27% slower approved, a slower decline. In fact, arithmetic, it was a mistake, and the results should be not 27%, but only 9%. And this is something we published in the medical journal to confront with the data. Lecanemab, actually the data is not 27% slower decline, but only 9% slow decline. The same thing with donanemab by Eli Lilly, based on their top results. They claim a 29% slower decline. In fact, arithmetic correction should be only 11% decline, right? On top of that, both drugs carry a very serious effect, ADRIA, which is brain swelling, and microhemorrhage accordingly. So let me give you the example. ASI drug, lecanemab, and aiodanemab, both drugs, by the way, marketed by ASI and Biogen. These drugs require PET scan and lumbar puncture. Okay, to be able to administer these drugs to the patient have to undergo a very expensive, invasive treatment. And only in the US, I don't know about other countries in the US, the treatment normally can be available in the medical centers. Many small clinics and many small hometown, they're not able to get access to this treatment because it requires PET scan, MRI, lumbar puncture every month. The patient take twice treatment intravenous a month. And the total cost is about $87,000 per person per year. And the patient usually in the US, they have to pay 20% yourself and 80% paid by Medicare. So this is pretty expensive, and not everybody can afford it. And I feel that only a small privileged people have the money and live in the metropolitan in the US are able to access to treatment, and many people may not be approached more accessible to this drug. Our drug, actually, the oral formulation, it for your information, is this a number? It much less than total cost is much less than lecanemab, and we have not yet get FDA approved yet. We're still in phase 3, but our project cost is very reasonable, and we could be changed if needed. So at the present time, we are conducting phase 3 trials for treatment, and because the drug is oral, we also plan to do a prevention treatment. In other words, people who have this adverse risk can take the drug when they develop some early symptoms, with the hope to delay the disease, with the hope to stop the disease based on the neurogenesis. So this is a ongoing program, and we are planning to do that shortly. So in the conclusion, we believe that the neurogenesis hypothesis is a viable approach. It could be a potential replacement of the current amyloid cascade hypothesis. And our drug actually shown to be generate new neurons in the hippocampus and improve the cognitive functions by stimulating neurogenesis. And in the phase 2 data show a proof of safety and efficacy. And we continue to do the further study in phase 3. And as a result, we believe that neurogenesis hypothesis is a viable guidance for further research in Alzheimer's disease. And I'd like to quote Professor Nicola Toni of Lausanne University in Switzerland. He's saying that even if drug companies could develop new therapeutics that block or reduce the amyloid beta, they will not able to reverse the damage. But the adult neurogenesis in the hippocampus could be a way to partially right that wrong. And we agree with Professor Tony, and we think that our study demonstrates that approach, and we believe that this is a viable approach, and we encourage our colleagues work with us and collaborate with us for the study in this field. With that, thank you very much for your interest and attention. I'd be happy to answer a question you may have. Okay.
Yeah,
I'm sorry,
perfect.
it may take a little bit more time than I planned, but any question?
That's fine. I hope our next speakers will understand it. As you had so much to share, like the list of drugs, amyloid hypothesis, challenges you faced, beneficial roles, safety and costs, and the plans you are having for the future, new hypotheses. There was so much. I am sure that everyone will understand why it took so much time or extra time. It was worth it, I'm sure. So I'm very thankful for your talk, Dr. Tran. So we were having some questions. We were having a few people asking for a discussion with you during your presentation. So let me call them for any kind of question or any kind of discussion they would like to have with you. Firstly, in the meeting room, dear attendees, you can ask your questions now. And it's not necessary that you will ask the question in the chat box only. You can come up on your screens and ask the questions. That way I'll feel like there is somebody else in the meeting room other than me and Dr. Trai.
Sorry.
Yeah. So it was, I think, Mr. Weil and Dr. Nadeem. They wanted to discuss something with you. If you still remember the question.
Okay, I don't know. Is that on the chat box?
We will receive the question in a while.
Okay.
Please give them a while. And also, if anybody is having any question to be asked from Dr. Tran in the LinkedIn Live also, please write down your question. And I think we can do this. Dear team, is it all right if we ask our LinkedIn attendees to ask the question in our discussion portal? So we can just try to transfer the questions in the meeting room right now.
Yes, I understand you may need time and I may need time to answer questions. So I don't want to hold back all the speakers. You feel free to send message to me through LinkedIn, and I'm happy to follow up and answer for you. Or after the meeting, I know with a limited time, I know all the speakers are ready to speak. So if you have any question, you ask me now. Otherwise, we can follow up with the LinkedIn. Okay. Thank you.
That's really kind of you and very understanding of you, Dr. Tran. But I think we could just take 5 minutes for the questionnaire session if anybody wants to ask the question right now. Um, so, dear team, do we have any question on the LinkedIn right now?
Okay, I think someone asked
Yep.
me about the timing for the phase 3 trial. Yes, we have finished a phase 2. We're going to do a phase 2B and phase 3 at the same time. We plan to do a phase 2B so that it quicker, and why we continue with phase 3. In the US, the FDA will approve the drug on the accelerated manner only with the phase 2B data, without a phase 3, and allow the company to continue do the phase 3 later on. So our company decided to do two program. One is phase 2B, which is bigger than we did phase 2A. And then we also initiated a phase 3 at the same time. So it will be concurrently at the same time. Phase 3 take a bit more patients and a little bit more longer. Instead of 12 months, it will be 18 months. So both data will be available a year from now or maybe 18 months from now. So thank you for asking the question.
Thank you for the question, Mr. Weil, and thank you for addressing the question, Dr. Tram.
Thank you.
All right. So any more questions from Dr. Tram?
By the way, I understand you are recording the
Yes,
Zoom,
we are.
and will you make the recording available for people who may miss it?
Yes. We'll be, yeah, the video will be presented or will be available on our YouTube channel as well.
Yeah, very nice.
Yeah. And it is a LinkedIn live also. So in case somebody miss the meeting right now, they can reach to our LinkedIn page also, LinkedIn account. Okay, there is one more question from LinkedIn. Somebody asked that how to improve neurogenesis. Is it possible?
Oh, very good question. In fact, as you can see in my presentation, neurogenesis is a natural phenomenon. And there are multiple states of neurogenesis. You could, in a very normal, healthy way, suppose you have a brain logging, you do not, you feel a little bit blurry in your brain and you don't feel well. In a very minor way, you can go out and have a good walk, do some exercise. Yeah, this actually true. I do myself too. Sometimes I work in the lab, there is sort of too much stress, and your mind somehow kind of cope with the demand of the job or a lot of pressure. We all know that if you stop, go for a walk, and you feel your mind clearer. It's true. It is very clear. In fact, they did animal studies saying that animals who do regular exercise, they maintain a very healthy neurogenesis, right? Our drug is designed to as a pharmaceutical intervention for some people who already passed that state of natural healthy. Only for people who sick, and there are many dementia people or Alzheimer's people, you cannot ask them go for walk every day. Even though you have walk every day, it boosts up a little bit, but it's not able to overcome the deficit of the neurogenesis lacking. So for all of us, the idea neurogenesis is very close to what we do every day. Frequent exercise, go for a walk, have a good, breathing air, and also eat some healthy food. It helps the brain to continue generate new neurons in a very healthy manner. Only thing when you get sick and your system begin to deteriorate so fast, right? At that time, the exercise, the food, the diet, even the music. People say you got to listen to music, you help you better. True. Um, I tell you my story. My dad suffering disease, and I at that time we were so panicked and don't know how to get treatment, and we, uh, turn on the cassette music. At that time we call cassette, not a CD, right? Music on every often, and he feel better. He can smiling. He can recognize the music help the brain to reconnect it, right? But unfortunately, when the patient go to a decline, it's so it needs the intervention. That's why our drug designed to help to facilitate, to boost up the defense system, right? And I'm only use it for the patients who need it, but for all of us who are healthy, good exercise, good food, try to work with less stress, because a lot of stress cause a lot of unhealthy oxidative, stress, and it causes a very out balance of our brain system, and as a result, you tend to be succumb to a lot of system. I must tell you that Alzheimer's disease is mysterious today. We understand only a portion of it. We don't understand many of it, and I think we on the beginning of a massive pioneer frontier to learn about what's going on. Unless we know truly what is the true reasons of the cause of Alzheimer's disease, we still, work on the very, new chapter territory, right? This is something we encourage many people, particularly young PhD, postdoctoral, encourage many of you, if you choose a career, this is a very interesting career. And I've done that before. And even today, after many years, I'm still like it. I encourage people. Wonderful, the idea.
Yeah, there is one more question. Then I'll
Like,
ask a question I got in my brain right now. So
uh,
we had one more question from Dr. Nadi. What
okay,
factors affect? I'm sorry.
okay. This is a very good question. Which factors affect the neurogenesis? Okay. Well, let's put this way. Neurogenesis is a natural phenomena of our brain. When we are born, all the way when we die, right? It continues generate new neurons. It thanks to the mother nature. Without that, we all of us, lost our mind and lost our ability to think, right? And so what are the factors um, affected? There are many factors. Okay, I can give you my understanding, and my understanding is pretty much limited to based on what we know. The phenomena of Alzheimer's disease caused by many factors. Many years ago, some professor, I know Professor Mark Smith, that back in the early 1920s, he proposed the idea of oxidation stress. He thinks that if you suffering yourself to a lot of stress, could be mental stress, could be chemical stress, your body created a free radical, and free radical affect how the brain functions. It affects the hippocampus. It affects many things. So he proposed the idea of oxidation stress. However, that was like 20 plus years ago. And since then, we don't see any drug that demonstrate his idea that oxidation stress is viable. But we take into account that the neurogenesis is one phenomena. There are many factors can affect the neurogenesis. And I believe oxidation stress is one of factors, many factors, right? Another one is the exposure of a hostile environment, exposure of a toxic environment. For example, if you live in the place where you constantly breathe, unhealthy air with a lot of carbon dioxide, a lot of pollution, a lot of toxin in the air, it constantly affects your brain, right? It not obviously, as you and I know, the brain is marvelous idea with a brain, barrier. The blood-brain barrier enable the brain to isolate itself from a lot of as toxic effect, a lot of environmental effect. That's why we're able to function in a very extreme condition. But if you continue expose yourself to extreme conditions, toxic conditions for so long, eventually it goes to your brain, right? And you no longer have a healthy mind. You become early dementia. For example, let me give you an example. That's a good question. Over the past few years, since the advent of pandemic, COVID-19 pandemic, I'm sure many of you in India, overseas, and mine in the US, we observed that many people suffering from COVID infection. And that back in early 2020, early 2021, we have the collected data. We find that um, many patients, in fact, now data show that it's not from us, but medical literature demonstrate that about 28 to 32% of patients who had severe cases of COVID-19 infection, who have been in the hospital in the US and been discharged, after that they go home. So they follow the patient over at least a year, since late 2021 to early 2023. And they published many thousand patients, particularly in clinical trials. And they say that those patients who suffering from severe case of COVID-19, you guess what? They suffering from dementia in the early age. Some of them only 40, 50, well below the threshold of dementia. And many of them complain that they're absent-minded. They lost their key. They don't know where. They keep their, laptop, and they walk around and say, I don't know what I did, and I forget. And this is very serious, because 1/3 of the people who suffering from COVID-19 have so-called long COVID. Many of you understand about long COVID, and long COVID is the phenomena that a patient suffering neurological impairment after a serious, infection of the virus. Because I gave a talk a while back about COVID-19 and the brain, and that back at that time we didn't have enough data in 2021 to show, but now a year passed and more clinical data show that it's true that the COVID-19 virus actually can able to penetrate the blood-brain barrier for some patients, not all of us, right? Luckily, some of us are still healthy, and some people cannot defend. So when the virus attack the blood barrier, the first thing first, it changed the ability of how the brain function. It affect the hippocampus, and immediately it lost the ability to make new neurons, So as a result, the patient begin to become brain foggy, they're forgetful, and it early symptoms of dementia. Since we just have COVID over the last couple of years, so data is still very new, but people are guessing that for those who unfortunately had severe case of COVID-19, they may probably start the neurodegenerative diseases sooner than anybody else. In other words, it may be 5 to several years earlier than normal. In other words, without the COVID-19 infection, suppose people have 75 years or 80 years to begin to get dementia. About 1/4 of people, more than 1/4 of people who 80 years of age have dementia, right? This is, we all know that. But unfortunately, with infection, it may occur sooner. So it may bring up to maybe 75, you begin to develop that early onset of dementia. So the wisdom is that we need to treat the COVID-19 and all the pathogens seriously, because some people may, even though they recover from the infection, but the brain suffering from potential, loss of neurons, and as a result, lack of neurogenesis. I'm sorry to give you a long answer, but if time permit, and I don't want to take a lot of your time, and feel free to write to me on LinkedIn. Okay, thank you.
That was indeed a like very informative. So I don't think anybody here would mind it. Yeah.
Thank you.
Yeah, so, all right, we'll be having one more question answer session at the end of this event. In between, with your permission, Dr. Tron, let us move to our next speakers.
Please.
Shall
Yeah.
we? Yeah.
Yes.
Thank you so much.
Thank you
Please
all. Thank
stay
you very much.
tuned.
Yeah.
Yeah, please stay tuned. We'll be having one more questionnaire session at the end. Yeah. Thank you so much. So everyone, let me introduce our next speakers. It's Dr. Uday Shankar Akash Venkala and Dr. Uday Shri Akkala Shetty. Please don't get confused with the names as I did. You will get to know what I'm talking about. It is a team of two people, two doctors.
Thank you so much. Thank you so much, Dr. Gazelle.
Welcome.
Thank you, Dr. Tran. It was a pleasure to meet you on this platform, and I would say that was a very amazing and informative session. And it's an honor to meet you, sir. Listening to your insights on Alzheimer's and everything made me appreciate this field even more. Thank you so much for that. And thank you for the introduction, Dr. Gazelle. I'm so sorry to leave you confused with that.
No, no, that's all right. It was my mistake, anyways. I thought it's just the same person, and that's why I was inquiring a lot.
Yeah, trust me, we do encounter that as well.
Yeah, I'm sure it should have happened so many times.
Sure. Can I move ahead now, right now? Can I share my screen?
Yeah, definitely.
Yeah, just
Please take your time.
yeah. So, good evening to one and all present here. I'm Dr. Uday Shankar Akash Vankala, as according to the introduction, and and there's also a co-author of mine, Dr. Uday Shri Akala Shetty. So we find it as a great pleasure to talk to you guys about this topic of glutaminergic modulation. So I hope everyone can see the screen. You can just drop a thumbs up in the chat box.
I can.
Yes.
Everyone can?
Yes.
Yeah.
Perfect.
So yeah, moving ahead. So what exactly this topic is based on is the glutaminergic modulation, unveiling the role in neuroplasticity and mental health disorders, and the other role of therapeutic agents. So just a small introduction about myself. So I'm a medical graduate from Malaradi Institute of Medical Sciences, currently pursuing a rotation in Dearborn Cardiology. And yeah, I'm not that qualified as Dr. Tran. So I would love to learn a lot of things from him. And in this pursuit of my journey of learning, and it's a great pleasure to meet you all, whoever is here. And I would love to know the other insights as well. So this is about my co-author. She'll introduce herself.
Good evening, everyone. I am Dr. Udaishi Akalashetty, a medical graduate from Malaradi Institute of Medical Sciences. I'm currently rotating as an extern in Dearborn Cardiology Hospital. So, as a doctor, I strongly believe that prevention is a key to building healthier communities, which inspired me to engage in research studies and activities. So, my ultimate goal is to contribute to the betterment of people's lives by preventing and treating diseases. Yeah. So moving ahead, Dr. Akash will start off with the topic.
Yeah. Thank you, guys. So the first pondering question in everyone's head about what neuroplasticity is. So let me put it in simple terms for you guys. So it's the ability of the neurons and other brain components to change in response to intrinsic and extrinsic inputs. So it includes a number of processes such as synaptic plasticity, neuronal growth, remodeling, and neurogenesis, and whose dysregulation can lead to a neuropsychiatric diseases. So as Dr. Tran has already mentioned in his previous talk, so when we are younger, the neurons are in a very juvenile state. But as we grow older, there's a constant process of remodeling which is occurring, and neurogenesis especially. So there is a different wiring of the neurons in between, causing us to adapt to different skills and learn a lot, and that is the basis of our intelligence, to put it in simple terms. But if these things are dysregulated, it can lead to a number of neuropsychiatric diseases such as a major depressive disorder, bipolar disorder, PTSD, and various others. So the intricate wiring of the brain is very much important. So how it gets wired is based on the factors or the inputs which occur. Might be an external factor, might be an internal factor, might be toxins, might be stress. So there are many other different things which result in this wiring of the brain. So talking about what is the significance of neuroplasticity. So patients with mood disorders are found to exhibit neuroplastic changes, such as reduction in hippocampal volumes, cortical volumes, glial and neuronal cell densities. So here is a simple picture illustrating like how the neurons are wired. So over here we can see the neurons in the temporal lobe being connected to the cerebellum. So if this wiring takes place in a different fashion, it might the neurons in the temporal lobe might be connected to the frontal lobe, which might be leading to any other form of dysregulated things. So the neuroplasticity significance is very much important in as they play an important role in mood disorders. So over here, we can see a picture of the brain, which indicates the neuronal firing when the brain is under stress. So we can just see how active the brain is under the stress. I mean, I know it sounds ironical, but yeah, during stress, there is a lot of firing of neurons, which actually stresses you out. So there have been numerous ideas being proposed to be linking about neuroplasticity and how it has been proposed to cause mood disorders. So there are two hypotheses which are primary: the monoamine hypothesis and the glutamate hypothesis. So right now, our focus of the first talk is to focus on glutamate. So which has considerably shown to have more significant development in the form of new drugs and therapies in mental health. So speaking about the glutamate hypothesis, what exactly is glutamate? So it is an excitatory neurotransmitter which is in the brain, and it has plays an important role in learning and memory. A vast majority of the neurons in the brain actually use glutamate as a primary neurotransmitter to carry out complex cognitive functions. So the neuroplastic changes in these circuits, if there is any sort of problem in these circuits, might lead to a biological underpinnings of the mood disorders that we are talking about. So here is a picture which exactly shows how glutamate is released and how glutamate is recycled. First, I'll go through the initial stages, how it actually goes in the normal human body. So over here, as we can see, the starting up, this is a vesicle of the glutamate containing the glutamate excited neurotransmitter. Whenever there is a stimulus, the sodium channels open and resulting in the release of glutamate into the synaptic cleft. So right over here. So this glutamate, which has been released into the synaptic cleft, goes on sticks onto the receptors on the postsynaptic neuron. Those are nothing but the NMDA receptors. So the downstream effects of these NMDA receptors result in the production of brain-derived neurotropic factors and also result in neuroplasticity. That is nothing but the changes which are happening in the neurons, which may be a good cause or else a bad cause. So just we shall just go through the how in case of a stress the neurons might respond. So when we have a stress over here, this is actually the stimulus. So this causes an abnormal firing of the sodium channels, causing excess amount of sodium influx, releasing excess amount of glutamate. So this glutamate, which is present in the synaptic cleft, constantly stimulates these NMDA receptors on the postsynaptic neurons and resulting in more amount of neuroplasticity. So this is one of the proposed theory. And And another theory which I would like to highlight is the third part over here. So usually in cases of the glutamate hypothesis, it has been already also told that the glutamate transporters which are present are also dysregulated, causing excess amount of glutamate to even reside in the in the synaptic cleft. So more amount of glutamate, more amount of NMDA receptor activation, more amount of neuroplasticity. So glutamate being an excitatory neurotransmitter results in more amount of excitation of the postsynaptic neuron. So I guess everyone in medicine does know this. Anything which is activated more is not exactly good. So over here, this term is called as the glutamate excitotoxicity. So we say it as excitation when it is in the proper amount, and more amount of activation, we say it as excitotoxicity. So this results in the depletion of the glutamate reserves in the presynaptic neuron, as well as overactivation of this postsynaptic neuron, causing a lot of amount of neuroplasticity, which is not exactly desired. So moving ahead, we I just wanted to highlight even the monoamine theory because it was mentioned earlier. So initially, monoamine theory did possess the simple terminology saying like serotonin, norepinephrine, and dopamine, which are depleted in the synaptic cleft, result in the mood disorders. But this thought process has been changing over time. And monoamine theory has been the basis of the production of the mood disorder medications like the SSRIs, SNRIs, and the TCAs. So what exactly they do is in the synaptic cleft, they increase the levels of the serotonin and the norepinephrine, which are present in the synaptic cleft. So which result in the resolving of the mood disorders. But the hypothesis has been changing over time. This glutamate hypothesis, which I have just told you right now, has been inspired from the mechanism of the general anesthetic ketamine. So this is one of the interesting point to be taken note of this in this talk, I would say. So this ketamine, usually what happens, the action of the ketamine also has been described over here. So ketamine actually results in the activation of the NMDA receptors of the GABAergic neurons. So GABA being an inhibitory neurotransmitter, so what it does is releases excess amount of glutamate over here in the other parts of the brain, releasing increased production of the brain-derived neurotrophic factor, which results in the neuroplasticity. So I guess everyone might be confused right now. Hold up, you say. So previously in the slide, I told like there's excess amount of glutamate, excess amount of neuroplasticity. Over here, also I do say that there is excess amount of neuroplasticity. But let me clarify that for you. So the mood disorders have been previously told like they're according to the glutamate hypothesis, there is some amount of excess neuroplasticity in few circuits and low amount of neuroplasticity in few circuits. Ketamine targets those which have the lowest neuroplasticity. So as increasing the neuroplasticity at the lower end usually balances out the mood disorders. That is the hypothesis of how ketamine works. So moving ahead, my co-author Udashri will actually describe about other parts of ketamine, other things of ketamine, and about the study analysis.
Thank you, Dr. Akash. So now talking a bit more about ketamine. Ketamine was approved for treatment-resistant depression and suicidal ideation. It can relieve symptoms rapidly and with sustained effects by regulating glutamate. So molecular neuroplastic changes that occur rapidly after exposure to ketamine encompass an increase in molecules involved in modulating neuroplasticity, particularly glutamate. Not only ketamine, talking about psychedelics have classically been seen as serotonergic substances. However, there is increasing evidence that their mode of action is closely related to the glutaminergic system and to neuroplasticity. Psychedelics robustly promote structural and functional neuroplasticity in key circuits relevant to brain health and mood. So, moving ahead, moving ahead, could you just change the slide, please? Yeah, so talking about the study analysis, several research studies into the neuroproductive effects and the neuroplasticity effects have proven glutamanergic psychedelics to be increasingly important. And also the studies of ketamine, the glutamanergic activity of ketamine is the main mechanism of action behind its rapid antidepressant effect. So, if we look at the monoamine theory, as Dr. Akash has said, according to this monoamine theory, there is depletion of serotonin and catecholamine. But studies have showed depletion of these hormones did not always result in depressed symptoms. If we look at the studies, only 30% of major depressive disorder patients who receive sufficient treatment enjoy full remission, while up to 46% of individuals with depression develop a treatment resistant depression when they do not respond to first line therapy. So, the neuroplasticity process underlying the quick antidepressant action of ketamine in major depressive disorder, bipolar disorder, and treatment resistant depression, reviewed by Kang et al., in both animals and people, paid attention to early molecular cascades that may be responsible for ketamine's antidepressant effects both in vivo and in vitro. So, this systemic study hypothesized that the primary mechanism of action of ketamine's fast antidepressant impact is its glutamanergic activity. Yeah, moving ahead, if you can see, Demchenko et al. Examined brain imaging studies in patients with major depressive disorders who are receiving glutamanergic pharmacotherapies, which showed quick antidepressant response. So, according to a few studies, glutamanergic changes also occur in bipolar disorder and other mood disorders as well, and also provide information on the neuroprotective and neuroplastic potential of ketamine and psychedelics as potential pharmacologic treatment for depressive symptoms. Branley et al. Performed a clinical trial which is also similar. So he examined the effects of low glutamate diet in anxiety, post-traumatic stress disorder, and depression in 40 veterans. And this result also showed the similar results. So yeah, moving ahead. So what is the take-home point of this? So the epitome, I should say, according to the conventional monoamine depletion studies, there is significantly limited role of monoamines in the pathophysiologic mechanism of mental health. The neuroplasticity hypothesis focused on glutamate may lead to a more considerable development of new drugs and therapies than monoamine hypothesis, suggesting a paradigm shift in the working hypothesis of mood disorders. Yeah, so these are a few references we used for our presentation. Thank you. I would like to thank the OLCIS Conference Board for this wonderful opportunity. Thank you.
Thank you so much, everyone, for your kind attention. And I know the talk was very superficial, but yes, I would say the other people who are hearing right over here, our take-home points would be like focusing on the glutamate theory, and any other sorts of advancements in the future, we would love to see them.
Thank you for the informative talk, Dr. Akash Venkala and Dr. Shri. Can I call you Dr. Shri? I'm sorry, I'm finally meeting you.
Sure, you can definitely call me Dr. Shri.
Thank you so much. I'm glad that I'm finally meeting you, and I couldn't take a moment to welcome you or introduce you
I am so
in between.
It's my pleasure meeting you. Thank you so much.
Same here. So this was very informative, and I'm sure everybody could get some more knowledge on the different aspects or scenarios related to neuroplasticity. And I would like to add that this was the very first time that we introduced this topic in our series of events, neuroplasticity. This is the very first event for neuroplasticity itself. So having three of you as our speaker, including Dr. Tran also, having three of you as our speaker is itself like feeling like worth it to add this event in the list. Thank you so much for joining and giving your efforts and time to us.
Thank you so much.
Yeah. So,
Thanks a lot.
moving to the questionnaire session, let me ask if anybody having anything to discuss with you or any questions to be asked.
Sure.
Yeah. Firstly, in the meeting room. And dear team, if you have any question then LinkedIn Live, you can please send the question in the chat box. Also, we are having Dr. Sampurnam in the meeting room right now. Hello, Dr. Sampurnam, am I audible to you? I think Dr. Sampurnam can add on something new to the information that we got in our event today. Hello, Dr. Sampurnam. Are you there? I guess it's again the network issues that we face. Oh, Dr. Sampurnam is here in the chat room. Would you like to add on something, Dr. Sampurnam? As I could see, oh, I could understand this. That was the very first thing that came up in my mind. That's okay. We got a question. The very first question for Dr. Akash and Dr. Shri.
Yeah, so I see the question as why shouldn't we use GABA modulators to regulate the high amount of glutamate as we treat those patients with epilepsy? Yeah, so this question is usually, I would say, because the GABA modulators in cases of epilepsy are the other regions which are being fired. So I would say the mood disorders which are actually focused are mostly on the hippocampal and the hippocampal regions, and those regions are usually activated by ketamine. And the other GABA modulators which usually work in epilepsy are mostly focused on the temporal lobes and usually in the frontal regions of the brain. I guess this does all answer your question, and I would say like Dr. Tran or anyone else who has more experience than me could help me out with this as well.
Thank you for addressing the question, Dr. Akash. I would have said the same thing, even though you answered the question. All right. I would have just invited our other two speakers to give an add-on if they want.
Sure.
Thank you for doing my job as well.
No problem. Thank you so much.
All right. Any more question or any add-ons? Please go ahead with it. And also, the people who are watching us on our LinkedIn Live, if you are having any question, please write down the question in the comment section and we will forward the question here in case you can't reach to the discussion portal. There is one more question from Dr. Sampurna. It's something to discuss, I guess. Hello, I hope I'm audible.
Yes. So is the question addressed to me or Dr. Tran?
Anyone can answer.
Sure. So I would say glutamate and aspartate biochemicals.
All right.
And
So will Dr. Tran add on to it?
yeah.
Yeah. Let me see. Okay, thank you, Dr. Van Kaya, and the team gave a very excellent overview presentation on the topics of glutamate excitation and idea. I think there is a common understanding of neuroplasticity. First of
Yes,
all, I
sir.
think the concept, why I focus on dementia and Alzheimer's disease, but let me share with you, most of the patients with the AD have suffering from neurological symptoms of severe depression. Because our brain is a wonderful way when one area was injured or not able to function well, it occurs a lot of symptoms, including dementia, loss of focus, loss of memory, but also the suffering a lot of severe depression. So the fact that NMDA and NMDA antagonist drug has been focused for the last many years. Some drugs, such as memantine, they focus on the mechanism action of NMDA, and it's so significant available treatment for symptoms of dementia. How unfortunately, because of the limitation and all the factors that cause adverse effect of memantine and all the related NMDA focused drug, it considering a symptoms modified drug. It's not a disease modified drug. Over the past in the US, over the past 20 years, there are about 5 drugs has been approved for symptoms modified drugs for dementia, Alzheimer's disease, such as Aricept and Memantine, example, and a few others. And nowadays, in our field, people begin to target disease-modified drugs, which is go directly to the heart of disease. And I think neuroplasticity, like our previous speakers, Dr. Shetty and Dr. Vekayala highlight, which is correct. I think we all are together to fighting a very relatively unknown. It is to me very
Yes,
uncharted
sir.
territory. Yeah. Each of us look in a different angle, but all together is true because all are related. And I'll share with you the fact that Alzheimer's disease may not be a one single disease. It is a multi-faceted disease. Even though we target one area of it, the time come, I think we need to use the combination therapy like cancer. You know, many physicians here can share with you that in oncology, we use a multi-drugs. We call it cocktail, right? Because treating a specific cancer diseases is not easy. You have to have multiple drugs. Maybe many cancer patients take 3 or 4, even 5 drugs simultaneously to target the biomarkers in a multiple angle. And that has been a common practice in oncology. Unfortunately, in neuroscience, we have not reached that level yet. Like today, the speakers after me spoke about the neuroplasticity and glutamate concept make a lot of sense, even though they target depression. But depression to me is one of the neurological disorders, which is totally linked with dementia and Alzheimer's disease. So the time come, I anticipate that we may have multiple drugs, okay, and together in a cocktail treatment, one target this angle, the other one another angle, and hopefully we can bring the significant, combination drug therapy to help the patient to overcome the challenge they're suffering in this process.
Thank you so much for the add-ons, Dr. Tran. And of course, I forgot to thank Dr. Akash for addressing the question.
Thank you so much.
All right. Any more questions? as this is finally the questionnaire session. Till then, till the time we are having questions, I would like to request to our attendees, only the attendees, we are already having the details of our speakers, of course. So, dear attendees, please share your full name along with your title. It is Dr., Mr., Miss, Professor, whatever it is, and your email address and your country name also this time. Please share these details in the chat room till the time we are having more questions to discuss. Miss Daisy, you asked a question earlier in the chat room. I hope you got the answer. If not, you can ask again. If any of you didn't get the answer of your questions, please ask your question again. I'd be glad to answer it. All right. Dr. Sampurnam, your details are on my tips right now. You are one of our OCM also, and like most regular speaker. So I remember every detail of yours. I don't even have to look for it. And yes, I would like to share something that Dr. Sampurnam will be the chairperson for our next event that will be on August 19th. And the event is one of my personally favorite one, that is on the psychology and human behavior. I would like to repeat it. Our next event will be on August 19th, and it will be on psychology and human behavior. So if you are interested in the event, please make sure you register as soon as possible. If you would like to present your talk or your research, please share your research abstract. Everything is available on the website, and in case you can't reach to it, please ask us. Make sure you are connected with us on all of our social media platforms, so you'll be updated with every upcoming activity in all shares. I'm again having the details in the LinkedIn Live also. I'm sorry, but according to the policies, it is mandatory to register yourself for the event first from the website and attend the event. I hope I'm not missing any information here. In case I did, we will definitely share it on the social media. I hope everyone has shared their details here. Okay, last call for the questions. If you are having any question from Dr. Tran, Dr. Akash, Dr. Shri, or to me, or with All Shares live conferences, please feel free to ask your question. Thank you, Mr. Whale. Thanks to you for joining us. The main goal is the comfort learning, Mr. Whale. We try our best to provide the platform to learn comfortably. and to share your research comfortably. Okay. All right. We have shared the discussion portal. It's linked on LinkedIn Live as well. So please make sure you are connected with us on the discussion group also. So in case you are having any questions, you can ask for it. Any answers you would like to add on, you can do the same. Thank you, dear Bellies Dora Yildiz. Do I need to repeat that what details we asked for? I hope everyone has shared their details. If you haven't, please ask me what I asked for. Okay, I have already announced about our next event, Psychology and Human Behavior, on August 19th. As I can see that many of our viewers from LinkedIn are from the psychology field. Yeah, we can definitely get more insights about the subject matter in our next event, I'm sure. Make sure you register in advance. Any questions? Okay, so I would like to thank Dr. Tran, Dr. Akash, and Dr. Shri to provide their precious time to all shares live conferences and share their research with us. Thank you so much for joining us today, and we hope to see you again in our future events.
Thank you so much for this wonderful opportunity. And I got to meet the legend, Dr. Tan over here. And thank you so much for this opportunity, I would say. And I would be looking forward to working with you in the soon.
Well, thank you very much, Dr. Azar, for your excellent organization. I know this is a very exciting opportunity for many of us to get together on LinkedIn and know each other. We can hope to connect through LinkedIn and further in network together. So once again, I know this is a lot of time consuming and hard work for you. So appreciate your time and thank you everybody for your interest, attention. All the best and hope to have a good weekend.
Exactly, a relaxing weekend also to all the hardworking medical field related people, the doctors, nurses, the students also.
Thank you so much, Dr. Gazelle.
Yeah, it's Ghazal only, and somebody's asked, yeah. Yeah, somebody's asked, like thanking me for the wonderful event. So Dr. Nadeem, it was the organization, and I am just a part of it. I'm really happy to be a part of All Shares. It is continuously providing me more insights and so many more things to learn. And thanks to Dr. Tran for the praises. All right. So we'll be leaving the meeting room on for next 10 minutes. In case you think of some new questions or things to discuss, you can ask us. Same here, Dr. Tran.
Thank you very much.
Thanks to you too. Here, Dr. Tran has shared the link of his website, the Biomed Industries. All right. It was pleasure meeting you all. Thank you so much for joining us today. It was Ghazal Johar, and we will meet again in our next event. Stay tuned on
Have
our
a great
social media
weekend, everyone.
platforms.
Thank you so much.
Thank you, everybody. The best.
You too.
Yeah. Have a good
Goodbye.
day.
Thank you, sir. Thank you so much.
Bye-bye and see you again.